this video, I'm going to show you Form 5, Chapter 9, second last chapter in the syllabus called Motion Along Straight Line. Now, this chapter would normally comes out in paper 2, section C. Okay, you will get to choose 2 questions from this section. This is one of those, and normally I would want my student to choose this question because it's rather straightforward and it's not too hard to be done. So it's kind of like a bonus question. Now, in order for you to really understand this chapter, first of all, you need to understand something. When an object is about a moving object, you have a ball. Initially, it is at a point. Maybe I would say this is my origin point. When t equals 0, is here. After a certain amount of time later, it is moving at the speed of v, velocity. Okay, moving towards the right, where I would define, this is here you need to define, my positive is towards the right. So velocity towards the right, what happens? T second later is here. So meaning it progresses from here to there. And then after a certain of time later, it stops here. T final stops here, meaning it decelerates. So the acceleration becomes 0. So what is important is, in this chapter, they will normally ask you at t time, how far it is from origin. It's always the case. What's the distance from here to here? From origin. Okay, so I think I'll do it this way. After a certain second later, what's your S? S is a displacement. Symbol S. Displacement is always referenced with your origin. How far is it from origin? Is it over the left hand side or right hand side? If over the right hand side is positive. If it were to be over the left hand side, then it will be negative. If it were to this side, then it will be negative from origin. Okay, it's always the case. It works like this. What's important here is the origin. Where is your point of reference? Where is the origin? And it's also possible when t is 0, this is the reference point or your origin point. When t is 0, your object is over right hand side already. This is where your t is 0. When t is 0 is already x distance. So what happened after a few seconds later, when it turns out to be here, then you need to plus the origin time. When t is 0, how far is it from origin? Because S is always defined as how far is it from origin. It's not defined by when t is 0. Unless when t is 0 is origin, then yeah, that's pretty simple. And how to do that in order to solve this chapter? So this question from this chapter, well, you need, what you need is what you have learned in Form 4 and also Form 5. And quadratic equation in Form 4. Differentiation in Form 4. As well as integration, Form 5. So if you haven't done those questions, if you haven't excelled those chapters, I would advise you not to watch this video, otherwise it will be very hard for you. And you want to switch to my other chapter, or go into those chapters that I mentioned earlier. Quadratic equation, differentiation, Form 4, and Form 5 you need integration. Okay. So to start out with, let me give an example. Normally, okay, before getting to an example, so they are going to have 3 terms here, right? I've earlier shown you. First is called the S displacement. velocity, and then acceleration as in A. So in physics we have learned velocity is defined as rate change of displacement. So therefore it's ds over dt. Whenever there's something over time, it's a rate change. Rate change of displacement is velocity. Whereas for acceleration, it's defined as rate change of velocity. That's why it's dv over dt. Okay, if you want to go from acceleration, from displacement to velocity, you differentiate the equation for differentiation, the equation for displacement. Likewise, if you want to, you were given acceleration. If you want to look for you want to look for the velocity. So therefore, what you do is you need to integrate a to dt. It works the other way around. Okay, you want to get v, bring it up. The same goes with if you want to get a displacement from velocity. All you need to do is you integrate v dt. Okay, so it's why is it so? Maybe I can show you here. As we define, v is actually ds over dt. Velocity is rate change of displacement. So therefore, if I were to bring up the, bring it up, times it up. Therefore, my s is basically displacement is integration of v dt. The same is true with the others. Okay, so without further ado, let me show you some example so that you have a better understanding for this chapter. Example number 1. So a particle moves along a straight line. It moves along a straight line. When a particle moves along a straight line, it's always good if you were to able to sketch it. Yeah? Then you come with that equation such that acceleration is given. The acceleration is 10 minus 2t, where t is in second. After it passed through a fixed point, at t, meaning when it passed through a fixed point at t, meaning when t is 0, is at origin. So this is the origin. When t is 0, how do I know? The keyword. After it passed through a fixed point O. This is my point O. The initial velocity, you were also told, the initial velocity is negative 16. So meaning initial velocity, meaning when t is 0, when t is 0, my v is negative 16 meter per second. So it means when t is 0, my object is not moving over the right, but is over the left. Negative 16 when t is 0. Okay. Assume the motion to the right is positive because I assume positive is to the right. So negative 16 is to the left. So first question, part 1. A. The maximum velocity of the particle. Now here, in order to really get the Vmax, all you need to do is that you need to integrate your acceleration. Now to do that, you need to find out what's the equation for v, when v is integration of a dt. So therefore, if I were to integrate the given equation, is here 10 bracket minus 2t dt. If I have to integrate that, that's why you need to know the equation. To know how to integrate. So this is you don't have limit, so you can't do it. But but you were told of this information when t is 0, v is negative 16. So when t is 0, v is 16. So therefore v is negative 16. So therefore negative 16 equals to c, and therefore my v is supposed to be 10t minus t squared minus 16. Now, if I want to look for the maximum velocity, so therefore for maximum minimum in Form 4 chapter 2, Form 4 chapter 10 differentiation, for maximum velocity, therefore dv over dx must be equal to 0. Okay, for maximum velocity, so you use the velocity equation, maximum dv dt equals 0. That's the rule, yeah, the turning point for this curve. So where would it be? I use where dv dt is actually acceleration. So what you do, you use the acceleration equation. 2t is equal to a. You equate to 0. Therefore, my time is actually 5 seconds. When t is 5 seconds, you get the maximum velocity. So therefore, my maximum velocity Vmax would be the equation that I have earlier, 10 times t minus t squared minus 16 meter per second. Number without units meaningless. Therefore, it will be 9 meter per second. Okay. So here, I think you will be a bit confused. Why is it like that? Okay. Given this equation. Now, if you look at this equation carefully, study it carefully, ax squared is a negative number. So therefore, this curve, you expect it to be a maximum. I don't know how it curve, but I think it's a maximum. It's a maximum curve. So if you were to plot, yeah, v versus t. If you want to know the maximum, so all you need to do, you dv dt equal to 0. Here is when the gradient is equal to 0, then you get a maximum point. So that's the reason to why you need to find what's dv dt for this curve for velocity to be maximum. Okay. How you refresh what you have learned. Right, okay. This is part A. As for part B, maybe they'll ask now the range of t which the particle moves to the right. Yeah, the particle moves to the right. Because from the question given, it's moving towards the left. So if you want to find out when it moves to the right, then all you need to do is either you look at the displacement or you look at this velocity. So when it's moved to the right, so right is my positive, so therefore the velocity is always in direction, right? The velocity v must be more than 0. It's to the right. If to the left, then velocity is less than 0. Okay, so here, if that's the requirement, therefore you rephrase the equation for velocity is 10t minus t squared minus 16 is my equation. If it were to be positive, therefore my 10t minus t squared 16 greater than 0. This is in inequalities. So my negative t squared is negative, so I bring it over so that I get a positive number, and therefore this tip is pointing towards the t squared, then it turns out to be t squared minus 10t plus 16 is less than 0. Okay, then from 5 chapter 2, You learn how to factorize t and t. Then negative 8, I think, negative 2, 16, you get 10, less than 0. And for this equation, is t squared is positive number, so you expect it to be a minimum curve, a U curve, where the root is 2, root is 8. But since you want for less than 0, so this is the region that fits into your condition. So therefore, the answer, the range, when particle moves to the right, particle moves to the right, is when the time is from 2 t 8. Solve this question. Okay. Part B. Then we come to part C. The total distance. Now they ask for total distance traveled by the particle in the first total distance travel in the first 6 seconds. So distance is the keyword, because as long as distance is involved, it doesn't really matter how far. It is about how far a particle moves. It's not that how. It's not a matter of how far it's from origin. Say for example, if you want to look for distance, what's the difference between distance and displacement would be, if I were to have an object, this is a reference point t0, it is here. If my object is moving towards the left hand side and then to the right and then come back here and okay, stops here after a certain amount of time. Okay, this is t0 when time is now t. Okay, so displacement is where the distance between the object, how far is from the origin. So this is displacement. This is displacement. However, distance traveled would be the distance from here to here. Maybe we'll use highlighter. Distance traveled would be here to here, and then here to here. So this is distance traveled. This one and this one is distance travel. Okay? So I hope you are quite clear by now. What does it mean by that? Okay? So, based on what we have earlier, particle of t move to the right. Okay? When it's moving to the right, it means this is moving to the left. Maybe t1, t1. When it's t2, the object is moving to the right. When it's t2, it's turning point. Okay? Okay? So when it's t2, it's moving to the right. So from t0 to t2 is moving to the left. And when will it be turning back again? We doesn't know. But as long as when it's 8 seconds, then it will turn to the right. Maybe it will turn back and forth. No, sorry. From t is 2 to t is 8, maybe t is 8, maybe here t is 8, it's moving to the right. So if you want to find out what's the first second distance travel, so what he'll do is the total distance travel in the first 6 seconds. So therefore total distance is also using the same equation, but now all you need to do is you need to have an integration 0 to 2 v dt, but you need to modulus it because for displacement you have a sign to the left is negative, so I want to find out the distance, so I use integration. I use modulus. So 0 from 2 is supposed to be negative, but I want the distance, so I put into a modulus, plus from 2 to 6 is somewhere here, but 8 is still to the right, so 2 to 6, when t is 2 equals 6, somewhere near here. So when I found this distance, all you have to do is to integrate from second to 6 second for v dt. Okay. Then if you integrate it, then it should look like what, 0 to 2. My v is 10t minus t squared minus 16 dt plus integration 2 to 6, 10t minus t squared minus 16 dt. Okay. So you may use a calculator if you have, and I hope you know how to use a calculator to perform integration. But if it doesn't have a calculator and doesn't know how to use a calculator to calculate the value for integration, then you need to use the long way plus 5t squared minus t3 over 3 minus 16t 2 to 6. So you calculate correctly, substitute them, therefore you should get a value like 41 1/3 meter. If you go to be measured meter, okay? Use a calculator, I'm sure you can do it because it's quite straightforward. So this is not just all about it, because you need, I will not be able to show you every single question. So I'll just pick a few that helps you to understand better. Okay, maybe I'll pick one more question. So that I'll be able to help you with that. But okay, I run short of paper, this book. Then let me my notes now. For additional maths. Now just ignore about this because I share book with Form 4 because I also run short with the other. Maybe I'll use another page. Okay. Here I'll maybe give another example. Yes, we are still doing Form 5, Chapter 9. Motion along straight line. Continue from previous example. I want to represent the next question in a graphical form, so that in hopes that you have to understand it better that way. So, says you are given a graph of displacement versus time, where this is positive direction, t measured in second, where displacement measured in meter. It looks like physics, but this is actually science, so don't expect much. So maybe you have a curve initially, and then a straight line, where the straight line equation s equals to 6t minus 30. My curve equation is s is equals to 0.3 t squared. Okay, so when my time here is 10, displacement is 30, but when my time here is 30, my displacement, if you substitute it into this equation, it would be 150. Okay? Alright. So the bicycle move along a straight road, its position is described as in a graph. So you want to construct, okay? You are asked to construct a VT curve and a AT curve. So this is how it comes out, in physics normally. You want to construct VT and AT graph for 0 to 30 second. Okay, so since velocity is ds over dt, velocity rate change of displacement, the VT graph can be determined by differentiating the equation, the S and T equation, right? So from here, from this region, 0, T, and 10, okay, what happened? My displacement S is 0.3 T squared. So having that say, my V will be therefore, if I were to differentiate it, ds over dt, differentiate, then it will get 0.6 T. Likewise, from 10 second, T less than 30, what happened? My displacement equation is 6T minus 30. My velocity is therefore 6. Okay, differentiate with T. Right? So, what happened? How to plot this graph? How to sketch this graph? So you want to sketch it, okay, then maybe it should look like, well, I want to construct a graph, V, positive V, T, okay, therefore from 0 to 10, it's a linear graph, mx, right, mx plus cmx, so I would expect it to be, when t is 10, my v is 6, so maybe 6, it will be linear. Okay, linear. When t 10 to 30 is a constant number 6, so it will be a horizontal line, 6, where t is 6. Okay, how do I get this value 6? How to get this value 6? Because from here, when t is 10, v is equals to 6. So I transfer this number into the value here. That's where I get this graph. Linear. How do I know? It's mx. Okay. Now next, I've done this. How about AT? Well, the same is true. I need to know the range because different range of graph, the graph is different. From 0 to 10, my V, I calculated just now 0.6T. Therefore, my acceleration is dv, rate change of velocity is acceleration. Therefore, it will be 0.6. Likewise, from 10, t, 20, or 30, sorry, second, v is 0.6, oops, sorry, what did I do? Based on here, it's 6, right? I've calculated earlier. It's here, 6. So therefore, my A, differentiate a constant, you get 0. Then how the graph should look like? try to have the same range of time. Acceleration versus time, measure in second. Acceleration measure is meter per second, 0. So when 0 to 10, the value is 0.6. So maybe here, doesn't really matter, I'm just sketching it, doesn't need to out to scale. Okay, 0 to 10. So when from 10 to 30, what happened is 0. So it's somewhere, it's here, 0. Okay, so this is the graph. If you were given S to T, you were asked to construct V to T. This is how you do it. And A to T. It shouldn't be so hard. All you need to know is to get to know what's the range. Different range, you have different equation. Okay, I think that's basically all about it. All you need to do is you need to spend some time, and then again, it's always about 25 to 30 questions about getting what's the displacement, what is the velocity, and what's the acceleration. 20 to question, 30 to 20 to 25 to 30 questions over a week time, over a week. And you have any questions, you may post me any questions over my comment, or you may go to a friend's discussion during a discussion, or you may ask your teacher at school to help you out with certain problems. Or there are some workbook that comes with working, especially those past year questions. They will have working, so maybe you will be able to learn from that. So with that, I think I sum up today's session and today's video, and good luck in trying this chapter. Thank you.